moving on. So inverse functions. The book has made it really complex when there is no need to, and I think they haven't thought how to solve these equations, inverse functions, or how to do it. So this is I've tried to put it in the most simplest way possible. So yeah, these 3 points are one of the most important things in inverse functions. Okay, the first point says that the inverse of a function is a function obtained by reflecting the graph of the original function across the line y equals x. I think that's very clear and straightforward. I'll just show you the graph. This is the graph. So you basically draw a line y equals x, and this is the original graph, meaning you'll have to reflect it over this line. So therefore you get this line, this graph. So that is the inverse. And the next point, property, domain of f of x becomes the range of f inverse of x. Oh yeah, this is how you denote an inverse function. It's f of this. By the way, this is not equal to f dash of x. This is basically dy by dx, which is calculus. So these two are very different. This is a dash, whereas this is a -1 on top of f. So f inverse of x. Yeah, this is how you denote it. And yeah, so domain of f of x becomes the range of f inverse of x. You'll soon know why. And also the vice versa holds true, meaning the range of f of x becomes the domain of f inverse of x. And for a function to have an inverse, it must be a one-to-one function. Even if a function is not a one-to-one, we can restrict the domain so that for that particular domain, the function is a one-to-one for that region itself, for that region only. So yeah, I think you'll learn that later. Like obviously it's not really mentioned in the book, but it's always there in the past papers. So yeah, just remember that you can restrict the domain to make a function one-to-one. Yeah, I'll show you how you'll restrict the domain. So we draw this on the Cartesian plane. We'll draw y equals x squared, which is a quadratic equation, and we'll draw a parabola which passes through the origin. So as we know, this is a function because it passes the vertical line test, but then we know that it's not a one-to-one function because it does not pass the horizontal line test, because it cuts the graph at more than one point. So hence we know that it is not a one-to-one function. So I'll show you how to restrict the domain. Okay, what you can do is either you can consider from this to this or this to this. Hence, it would be considered as a one-to-one function because it does pass. If we delete this portion, and this would be considered as a one-to-one function. So that's how you restrict the domain. You can state the value. So f of x, y equals x squared for x greater than or equal to 0. This is how you restrict the domain. So for this value, this is a one-to-one function. For this range, for this domain, this function is a one-to-one. So therefore, that's how you restrict the domain. Yeah. Okay, so this is the graph that I showed you. In the book, they haven't really mentioned how to solve these problems, but I've encountered these type of problems maybe every 2 papers. So I'll just explain it. So step 1, you'll have to swap x and y and make y the subject of the equation, and you'll have to replace y with f of x. So first I'll show a very simple example. which is, I'll just take y equals x minus 3. I think this is the most simple you can go. And replacing y and x, we get x equals y minus 3, and we'll have to make this the subject of the equation. So by transposing this side, we'll get y, we'll make y as the subject of the equation. So this, so therefore f inverse of x equals x plus 3. So this is how you find the inverse. And let's try a little more complex. So y equals x plus 1 divided by 2x minus 3. Oh yeah, just try to solve it first, and then you can pause the video now. I'll just do it now. You can solve it, and then once you have done, you can follow. So y equals x plus 1 divided by 2x minus 3. Now swap these two variables. So that would mean x equals y plus 1 divided by 2y minus 3. Let's multiply both sides by 2x minus 3. So that would be x into 2y minus 3 equals to y plus 1. Let's just multiply this. 2xy minus 3x equals y plus 1. Let's transpose it this side. So that would be 2xy minus y equals 3x plus 1. Let's take y as a common factor. So 2x minus 1 equals 3x plus 1, implies y equals 3x plus 1 divided by 2x minus 1. Therefore f inverse of x equals 3x plus 1 divided by 2x minus 1. So this is the answer. Yeah. I'll just solve the other one also. The other one is very similar. I thought of not solving it, but then I'll have to give the answer, so I'll have to work it out. X plus 1 divided by 2x minus 5. So 2x minus 5. Oh, I forgot to swap the variables. That is x equals y plus 1 divided by 2y minus 5, implies that 2y minus 5 into x equals y plus 1. 2xy minus 5x equals y plus 1. 2xy minus y equals 5x plus 1, implies y into 2x minus 1 equals 5x plus 1, implies y equals 5x plus 1 divided by 2x minus 1. Therefore f inverse of x this value. Yeah, that's it. That's all you need to know for functions. Yeah, bye.